Let's take a quick look at the calendar. Today is February 4th, class number 5. We're going to talk about a really important characteristic of lines, and that characteristic is slope. This will tie into the GeoGebra assignment that many of you have finished already, but I'm still waiting on from a few of you, where you typed in equations like y equals 2x and y equals 3x and y equals 4x. And it turned out that the number, the m, has a name. It's called this slope. So we'll talk about that today. Coming sooner than you like is quest number 1. Is that this Friday? Am I reading that right? Okay, so quest number 1 is coming up on Friday. It covers classes 1 through 5, which means from the start of the semester until today, including today. Wednesday, we're going to move on and talk about a new section, but Wednesday's material will not be on the quest. Okay? In terms of resources for the quest, let's just see if we can't find too far down the road here. We should see some sample problems. If anybody can help me out and tell me where they are. Maybe it's back here, actually. So it should say something like sample problems for quest number 1. Thank you, 35. So if you jump to page 35, just want to let you know about this resource. It is definitely not too early to start studying for this thing on Friday. So right up here, you will find a bunch of practice problems to help you prepare for the quest. So there's a lot of them here about solving equations. On the next page, it's about interpreting intercepts. And you keep going. Eventually, you'll find some word problems. And then after all that, you'll find an answer key. So I do have answers typed out for you on page 39, so you can check your work. But maybe more useful than just the straight answer key, if you go onto Moodle, you will find a PDF that I made where I wrote out the solutions, not just the answers, but actually all the step-by-step solutions. So that's a PDF up on Moodle. Check it out. If you have any trouble accessing it, let me know. And then finally, if you go to YouTube, and right here on page 35, it tells you what to search for. 106 sample quest 1 problem 5, for example. So I'm going to type that in the YouTube search bar. 106 sample quest 1 problem 5. And if I do that, you will find right here a video of me going through problem number 5. In fact, there's a whole playlist that pops up right before. I'll click on this thing. And let's come over here to problem 5 real quick. So 5 is this one here about a can of soda. And so if there's a particular part of this problem that was difficult for you, you can just find it, or you can watch the whole video, but you'll hear me talking and you'll see me once it stops buffering. You'll see me going through and writing things down, just like that, okay? I made a video for every single one of the practice problems for this quest and for the whole semester. So these videos are up there, and I'm hoping to get lots of hits because I want you to use them, okay? Yes? It's actually written right on, it's written right in the packet itself. If you're on page 35, you can highlight that phrase right there. That's how you find it. If you put spaces in there, you won't find it. If you type my name, you won't find it. You have to type that. Yes, Katrina. I have not. Good question. I'm going to write it down and think about it. I suspect the answer is going to be a no, but I'm going to think about it. Okay. Any other questions about resources or trying to prepare for this thing on Friday? Okay, and then the last thing we'll say before we jump into the new stuff is that, again, I will accept late homework. So some of you have a few homework assignments that you never got to me. I'll accept them all on Friday, but I will not accept homework after Friday for these first 6 classes, okay? So that's the last chance to get late homework collected. You bring it in on Friday. I'll spend the period grading it while you take the quest. Yeah. That's a good question. I think that they are, but I don't recall. There are some quests where it's a yes on the calculators and others where there's a no, and I don't remember for this one. I'm going to write that down. I'll answer it next time. Any other questions on that? Yeah, we have nothing planned for Friday except for taking this quest. Yeah. Okay, and in terms of, so I want people to feel like they have enough time to show me what they can do. You know, we've got 20 different people here with 20 different processing speeds, right? And I want everybody to feel comfortable and feel like they have time to do to show me what they know. So how about we say, if you want some extra time, we can start a little bit early. Instead of starting at 1, we could start at 12:30. Does that work? Is there anybody who would like to start at 12:30 but can't for logistical reasons? Okay, so we start at 12:30. That gives everybody half an hour, and I might be able to give us a little bit of extra time after class if there are people who need it on the other end too, okay? But if you do want extra time, show up for 12:30 on Friday. Okay. All right, so we're here back on page 22. And today we talk all about slope. So there was this example that I think hopefully folks had a chance to look at. So which of those two guy wires is the steeper one, A or B? One vote for A. Any other votes? One more vote for A. Is it clear? I mean, it's clear A is steeper, right? So the question is there something numerical that we can look at, that we can calculate that will tell us which one is steeper? And it's pretty clear in this case because both pictures are right in the same spot. But if I gave you one line here and another line that was, you know, like someplace that's sort of hard to compare, might be not as clear which one is steeper. The one is a little bit steeper, I think, the one on the left. But it could be so close that it's hard to tell just by looking at a picture. So we want to give us a really solid way to figure out which line is steeper and by how much, and that way is called slope. So let's fill in the blanks in number 2. Guy wire A rises how many feet? 10 feet, and guy wire B rises 2.5 feet, and it's exactly over the same 5 feet of horizontal. So in this case, it's pretty easy to say, oh, okay, they both go horizontally 5 feet. So whichever one goes vertically more is steeper. But what if they don't both go horizontally the same? So let's go to number 3, and we'll start with Drew. Okay, so the steepness of guy wire A we are defining right now. It's a change in vertical distance over change in horizontal distance. We're going to use that definition for steepness the whole semester. So it's not going to change. It is always change in vertical over change in horizontal. So the change in the vertical for guy wire A was how much? How much was the vertical change? It was 10 feet. And divide that by the horizontal change, which was 5 feet. And we end up getting 2 over 1, if you want to write it as a fraction. And that's it. And let's do the same kind of thing for the steepness of guy wire. Oh, question? Michelle? Yeah, this guy actually doesn't have units because the feet cancel. So it's just a 2 over 1 it's not feet, it's not anything. But really, it just means that for every 1 foot horizontal, the line goes 2 feet vertically. Yes, it's a pitch. Yes, very good. Okay, let's take a look at cable B. It's the same definition, vertical over horizontal every time. What's the vertical change for B? It's 2.5. And the horizontal change for B was also 5. It was the same. And we can reduce this, and we can get a 1/2. Which one of these ratios, these fractions, was bigger? Yeah, so A was bigger than B, right? And so what that means to us is that if the steepness ratio is bigger, then the line is steeper. That's the only conclusion we can come to. We looked at the picture. We all said, which one is steeper? A. Everybody says A is steeper. Now I'm defining this thing, and we're looking at the numbers, and we're saying, oh, look, A has a 2, and B is only a 1/2. So this is the connection. The bigger this steepness ratio, the steeper the line. That's our conclusion. The bigger the ratio, the steeper the line. Okay, let's go to Davis for number 5. Okay, so let's try this one. So we'll do road A. I'll do it in blue. So just look at the numbers for A. How much is the vertical for A? It's 120. How much is the horizontal for A? 4250. You just have to put them in the right spots. Which one always goes on top? Vertical. Vertical over horizontal. So vertical, it says it climbs for 120 feet. So that's the 120 divided by the horizontal. It's 4250. It's some messy decimal. You can type it in the calculator if we're interested. But whatever that thing is, that's a measure of how steep that road is. And then we're going to compare. I'll do road B in purple. So it says B climbs for 95 feet, and it's a horizontal of 2875. So for B, which one goes on top? 95, and on the bottom, 2875. And I have no way of knowing really which one of these is bigger until I go to the calculator. Like I can tell that road A climbs more, right? Road A goes 120 feet up, whereas road B only goes 95 feet up, but that's not enough information because road A travels horizontally more. And so it's really a matter of like, comparing these ratios. So let's type these two numbers into the calculator. What's the first one, roughly? 0.028. It doesn't tell me anything yet about whether that's the steeper one. It's only going to be there for comparison purposes. How much is the other one when we type it in? 0.033. So those numbers don't mean anything to me by themselves, but I can compare them. So which road is steeper, A or B? B is steeper because it's bigger. This is the thing we wrote right up there in red. Bigger number, steeper the line. So B is steeper. Evan. Yeah. Yeah, if you can reduce, I always encourage you to do that. And so, like, definitely on the blue fraction, what could you cancel right away without really even thinking about it? You can cancel the zeros, so that already makes life better. And the purple, what number goes into both? 5 definitely goes into both. So certainly reducing makes things easier. Yeah, and that would be a good way to get a handle. Ultimately, for me, I like having the decimals. I think that's the easiest way to go. Without a calculator, I think to compare fractions, like if you had 3/4 and you were trying to compare that to, say, 5/8, I think if you multiply and you multiply, you can compare those two numbers, and that will tell you which one is bigger. But I always forget which one is supposed to be bigger when you multiply. So I can never do that. But if you multiply 3 and 8, you get 24. 4 and 5 is 20. The conclusion is 3/4 is bigger, but I can never remember why, like which one is supposed to tell me which is bigger, so I can't do that reliably. Good question. Okay, number 6. We are back to Katrina. Okay, so slope is our new word. You just have to do the change in y coordinate and divide it by the change in x coordinate. That is supposed to remind us of the change in vertical over the change in horizontal. Okay? And then really trying to get us a sense of movement. Oftentimes we use the words rise and run. Rise for any vertical movement, run as if you're running on the ground, just horizontally left and right. And then here's an important note. We'll go to Aaron for the note. Okay, thank you. Okay, we'll go to Joe in the back for 7. Okay, so let's pause there and do that. So -2, -2. Put an A next to that point on the graph. So for me, that's red. I don't think you guys have a color version, but it's the one on the lower left. And then the other point is 2, 4. Everyone agree? Okay, so here's what we're going to do. We're going to try to calculate this new thing called slope. And we're going to do it by moving along the line from A to B. And as we move along the line from A to B, we have two different kinds of movements. You have a movement that goes up just the right amount, and then you have another movement that goes to the right. So all we need to do is figure out how long those little lines are. So you're perfectly welcome to count boxes, and maybe that's the first thing to do. How many boxes do we go up going from A along the purple line? We go up 6 boxes. Everybody count that? Count real carefully. That's a distance of 6. So this vertical change here is 6, and you can fill that in the blank. The y coordinate changes by 6 units. But it's possible that instead of being something small where you can count boxes, I could give you things that were hundreds apart. I wouldn't expect you to sit there and count hundreds of boxes. I could also give you something where it's not a perfect number, it's really a fraction, like it's part of a box at the end. So we want a more reliable way than counting boxes. So what's the reliable way? Well, how come it's 6? It's 6 because at the top, the y coordinate is 4, and at the bottom point, the y coordinate is -2. How far apart are those two numbers? They're 6 apart, and there's a very reliable way to get that, and the reliable way is to take 4 and subtract -2. And if you do that, 2 minuses make a plus, so that's really 4 plus 2, which is 6. So that's the easiest way to do that. And we'll play the same game horizontally. So first, just count boxes. How many horizontal boxes are there? It's like 4. Let's see if we can figure out the 4 without counting boxes. So we end at +2 and we start at -2. And if we subtract those numbers, 2 minus -2, what do we get? We get 4. So the slope of the line, here's a little formula, change in y divided by change in x. And I'm going to write my calculations just like I did over there. I'm going to look at the y's, they're circled in purple, and I'm going to subtract them. And we always subtract them. 4 minus -2. Does everybody see where those two numbers came from? They're both circled in blue. So we subtract the y's and divide by, and then we subtract the x's. So the x's are boxed in green, 2 minus -2. Questions on where the green numbers came from? Okay, so we can crunch them together. Upstairs is how much? 6 divided by downstairs, 4. That's fine, but we'll go ahead and reduce it to 3/2. And I'll tell you that whenever you do one of these slope calculations, we've just seen the definition, change in y over change in x, there's really only 2 fundamental ways we can make a mistake when we're doing this. The first fundamental way we can make a mistake is to get these things upside down. The y always goes above, the x always goes on the bottom. I don't have any cute like Johnny Depp thing. Maybe you guys can figure something out, like help us out. If you come up with some clever way to remember y on top, x on the bottom, share with us. Because that's one way we can make a mistake, is if we put them in the wrong order. The other way we can make a mistake is in subtracting. Now I did 4 minus -2, so I subtracted in this order, 4 minus -2. If I were not careful, I might try subtracting in the other order downstairs, and that's a mistake. Doesn't make any difference how you subtract first, but once you've decided how you're subtracting on top, you need to subtract in the same order downstairs. 2 minus -2. Michelle.
I'm lost on how you decided which order to go in.
Yeah, I made a choice, and actually we could have made the other choice, so let's make sure that we see that we'll get the same thing even if we do it in the other order. So -2, -2, and then 2, 4. Suppose that we were to subtract this way. So upstairs, we'll get -2 minus 4. -2 minus 4. Downstairs, can you guys write down? You can squeeze it in there. Put what you get when you subtract in that same order downstairs. -2 minus 2, says Evan. Do we see where that came from? Okay, upstairs, what do we get? That's -6. That's really frightening because we got 6 before. Well, let's keep going. Downstairs, how much do we get? -4. Aha! That negative and that negative cancel each other because they're being divided. So this is really the same as 6/4, which is the same as the 3/2 we got before. So Michelle says, how did I know which way to subtract? I didn't, I just picked, and you can pick. All I'm saying is that you better pick consistently. Once you've made your choice for how to subtract upstairs, make the same choice for downstairs. Michelle, does that help?
Yeah.
Okay. So the slope is 3/2, which I'll draw another picture here, which actually means that if you pick any 2 points on this line, or if you pick 1 point on the line, you can get to another point on the line by going 3 up and 2 to the right. Remember, the top number is the vertical, bottom number is horizontal. So if I start with this black point right down here, if I go 3 up, 1, 2, 3, I'm just counting boxes. And then how far to the right? 2 to the right. Where do I land? Right back on the line. And if you take that point and you go 3 up and 2 to the right, you will land right back on the line. And it makes no difference which 2 points you pick. You will always end up with this 3 to 2 after you reduce. Yes? From reducing. Yeah. Okay. Let's take a look at this next shorthand way. I think we're up to Jenny. A shorthand notation. Please. Okay. Sorry. So lots of ways to think about slope. We've got a bunch of them here. So first of all, the word slope, we just picked it. M is the letter that we use to stand for slope. In fact, where have you seen the letter M recently in your homework? Is on that GeoGebra assignment. It wasn't just a random choice to use that letter M. It's this M. It's the slope. So in English, it's the change in the y coordinate over change in x coordinate. In symbols, we can use this Greek letter. It looks like a triangle. It's the capital D in the Greek alphabet, and it is pronounced delta. It's written right up there. So delta just means change in. It means subtract. So it's a change in y over change in x, or if you want to think about movement, it's a rise over a run. Lots of ways to think about slope. Let's move on to number 8. Can you guys try this one? We'll get Glenn to read it. Okay, so give that a shot. Okay, so I know a bunch of people are now on page 28, but let's come back. Let's come back to whatever page we were on before. And we're going to just talk about number 8, 9, and 10. So this page doesn't really have the other one we were on before. Yeah, that one. Okay, can everybody get back to this page with 8 and 9 up at the top? Let's go back to right where we were. Okay, so I think everybody came around. I think everybody came around to slope of 5 for the first one. Super. By the way, 5 is the biggest slope that we had seen so far. 5 is also the what line of all the ones we've seen so far. It's also the steepest. If you imagine trying to climb up this, I mean, you can't walk up this. You'd need like rappelling gear to get up a slope of 5. 5 is a big slope, which means the line is very steep. Compare that to the line right there, not as steep. And look, the slope is not as big. It's 3/2, which is about 1.5. Now, trust me when I say 1.5 is probably steeper than anything we've ever walked on, but still, it's not nearly as steep as the 5 that we saw on the other page. I don't know if anybody watched some of the Winter X Games. I think it was 2 weekends ago. So you know, they go on these crazy steep downhill things and these crazy steep ramps uphill, and the slopes of those things are like right around 1, and they're crazy steep, right? So like when you go outside, you're not on anything like a 1 or a 2 or a 5. We're on things that are very, very close to what number? 0. Like 0 is horizontal, and so even something that we would walk out and like you walk up this big hill and you feel it in your quads and your calves, like yeah, it's like 0.2 or 0.3. I mean, like it's like we are not on anything like this or a slope of 5, but still we can compare. The bigger the number, the steeper the line. What's the difference between all the other lines we've seen and this slope of -2/3? This is our first what kind of number? This is our first declining line. And what kind of a slope did it have? It had a negative. So here's another observation for us. A positive slope is going uphill. A negative slope is going downhill. And on the very first class, so a bunch of you weren't here for that one, we said, Davis? That's right. So we've got the two different kinds of slopes right here. Positive is the first one, negative is the second one. And what we said on the very first day is when you read the line to decide whether you're going uphill or downhill, you read left to right, just like you read a sentence in English. See, I mean, like the first line, I'm saying the first line is going uphill because I'm choosing to walk that way. But I could just as well walk the other direction on that line, and now I'm going downhill. So we need to be consistent to decide what we mean by uphill. And what I said on the first day is you read the line left to right. Always, always, always left to right. And in this case, when you go left to right, you are walking uphill on the line. Over here, when you go left to right, you are walking downhill on the line. Positive slope, uphill, negative slope, downhill. We'll talk more about that soon enough. One other thing I want to say, I'm really not a fan of writing numbers like that, 2 over -3. I'm also not a fan of writing it as -2 over +3. I am a fan of writing it as -2/3. Now, all three of them are correct and all three of them are full credit, but I want you guys to have the confidence to know that you can take that negative sign from the fraction and put it anywhere, and in particular, the standard is to just put it in the front. And I say it could go anywhere because you could think of it in either way. So let's take a look at this guy. That -2 is a vertical change. If I say change vertically by -2, which way are we going? We're going down. So if I take a point on this line, say this guy right here, and I say vertically change by -2, that's down 2. And now that's a horizontal change of +3. Positives are to the right. So we go 3 to the right, and look, lo and behold, you're on another point on the graph. Or I could have read it like this guy. Now the vertical change is +2. So for example, I could start here, +2, fine. What does the -3 mean downstairs? It's 3 left because it's negative and the negative x's are to the left. So if I go 3 to the left, lo and behold, you land right back on the line again. So it really makes no difference which way you write it or which way you interpret it. They're both valid. For me, I like having a negative in the front. All right, so let's take a look at 10. And for number 10, Glenn, did you read yet? Yes, Melanie? Okay, so here's another thing I'd like you to be able to do. And this will just give us more slope practice. I'd like to be able to give you a bunch of points and ask you whether it's a line. Now, one way to determine whether it's a line would be to plot all the points one at a time and just see. I would argue, number one, that's a little bit time consuming. And number two, just because it looks like a line, does it mean it's perfectly a line? You're gonna have to do estimating, right? Like if you're plotting points, you're estimating there. If you're deciding whether it looks like they fall on a line, you're estimating there. So let's see if we can just do our slope calculation. So how about we take a look at these 2 points right here and do the slope. So we do, which one goes on top, x or y? Y. So we do subtract the y's. So I'm going to subtract 2 minus 4. That's an arbitrary choice. You can subtract either way. But for my choice, what number has to go first downstairs? Has to be the -4 and then subtract -3. Everybody see it? Be consistent when you subtract. So let's clean this up. Upstairs is really -2. Downstairs is really -1. Right? careful with all those negatives, and then cancel this and we get 2. Did I make a mistake? 2 minus 4. I think it works out to positive. Let's take a look. 2 minus 4. No, that part is good, but 2 minus 4. Got to fix that number right there. There you go. Okay, so if all of these points lie on a line, then the slope of that line is 2. But let's just go ahead and pick these 2 points and see if the slope is still what? Still 2. Because if it's not 2, then we had like first 2 points on one line and then the second 2 points on a different line. So not a line at all. So there I got a slope of 4, is that right? So are those points on the same line? No. So as soon as we see different numbers, definitely not a line. You don't have to do the last pair of points.
So if I were to do the, say that it was a pair of coordinates that I took the largest line, the smallest line,
Mm-hmm.
it would still be the same. Like say it was 2.
It would still be 2. Both numbers would be bigger, but they would cancel perfectly and get you the same 2 every time.
Okay.
Yeah, and this is something that Jenny read, and maybe I should have put it later in the notes, but I think Jenny read to us that the slope of the line does not depend on which points you pick. Doesn't matter which points you pick, you're always going to get the same number. So let's take a look at the middle example here. So go ahead and find the slope of the line connecting those 2. In fact, maybe divvy up the work because there's a lot of work here. So one person can find the slope of the circled blue ones up here, the first 2 points. Somebody else can do the purple ones. Somebody else can do the green one. So divvy that up and let's see how we compare with these numbers. So before we reduce, what do we get? So upstairs could be a 6 over -9 maybe. One of them will be positive and one will be negative. You have to make sure you subtract in the same order. So is that a line? Yes, all of them are -2/3. And this is a good example of what Evan had been talking about. For the first example, it was just -2/3 and that was it. For the second example, the numbers were much bigger, but they reduce proportionally and you get exactly the same thing. Yeah. Any questions on this one? Okay. How about the last one? Again, divvy up the work. Somebody do blue, somebody else purple, and somebody else green. So the first 2 points, 0 over 1 or 0 over -1. How much is that really? That's really 0. If you have 0 out of something, it's just plain old 0. How about the next one? How much is 0 over 2? That's also 0. And the last one is also 0. So is that a line? It is. It is. And what's the slope of that line? 0, which is a perfectly good number. Okay. Number 11. I think we are up here to Ben. Okay, so we've seen this picture before, I think. We had that equation, and we had the balloon falling as we released the helium from the balloon. And we talked a little bit about what the y-intercept represented. 800. What does that mean? Yeah, it starts, that's the zero part. Let's see, 0 minutes into this experiment, the balloon is 800 feet off the ground. So it starts 800 feet and then it starts to fall. And then we had down here the horizontal intercept, which is 40. So after 4 minutes, the balloon is 0 feet off the ground. It's on the ground after 4 minutes. Okay, but now we're going to talk about the slope. So part A, choose any 2 points on the line to compute its slope. And you have lots of freedom in terms of picking points, but pick points that are on the grid. You want something that's on the line that's also on the grid. The slope I got was negative 200. Agree? So we're going to pick 2 points. We're going to put that away, and we're going to pick 2 points that are on the line. For example, that one. Write the coordinates. Yeah, so something comma something. What are the coordinates of that point? So give me some parentheses right here, like open parentheses and close parentheses. Yes, 0 and then 800. Good. And then you pick another point, and then you find the slope. Okay, so the slope is negative 200. Even if you pick different points, you could have picked the points that I wrote first, 0, 800, and 40. When you reduce, you'll end up with exactly the same answer. Now that negative 200 means something, and so this is a really important part of what we're after today, is what does the slope mean in this situation? And we want to write a sentence in plain English, something that really anybody could read, even if they didn't know what we know about slope. So the first thing that I like to do in terms of thinking about what a slope means is to write down the units. Up here, I subtracted 800 and 600. What were the units for 800 and 600? They were feet. So when I subtracted and I got 200, I got 200 feet. And then downstairs, I subtracted 0 and 1. What were those measured in? Those were minutes. So ultimately downstairs, it's minutes. And I think just by thinking about feet per minute, I already am starting to understand what that slope represents. It is some measure in feet per minute. Okay, so in this case, I might have to go back on what I'd said before. You could think of it as gaining 200 feet of altitude every negative 1 minute, but that's not such a great way to think of that number. For me, I know I said I always put the negative sign in the front. Well, not here. Here I'm putting that negative sign upstairs, firmly upstairs. And I have the freedom to put it wherever I want. I'll choose to put it up there so that then I can say you lose 200 feet of altitude every 1 minute that passes. And so I can write that, and that's pretty close to being a sentence in plain English. So I'm going to write it this way. The altitude changes by negative 200 feet per 1 minute. If you want to do better than me, yes, you say that. The balloon is falling at 200 feet per minute. Yeah, it is. So we'll give people a moment to write, and then we'll talk about the 2 sentences. Okay, so my kind of awkward sentence written in black up there is really just copying the 2 numbers that I have. I have a negative 200 and I have a 1. And I'm just copying them, throwing a couple of words around to describe what they mean. So that negative 200 feet has to do with altitude. I just slapped the word altitude in front. And the 1 on the bottom is 1 minute's time. But then Melanie improved on it. So I've got my kind of standard. Here's how I write my slope interpretation. But then let's try to write it in plainer English. Let's make it really clear. The balloon is falling. Why did Melanie introduce the word falling? Because it is going down. But what about that number? Did she say it means falling? It's the negative, right? That's why it's falling. It's because it's negative. Melanie didn't say negative 200, did she? No, she traded. I said negative 200, and it was kind of awkward. She made a trade and made it sound much better. The trade was negative really means falling. So you use the word falling, and then you don't have negative anymore. Yeah, then that might be kind of rising. Yeah, and then per minute. It's silly to say per 1 minute. Melanie wrote it better. She said per minute. Let's assume that 1 minute has passed. Okay, any questions on that one? All right, so got about 15 minutes left. There's this group activity that starts here on page 25, but you might want to, I know I interrupted people from question number 3, so maybe jump back to wherever you were on page 28, and if you finish number 3, then you can come back here to page 25. I'll walk around and help if I can, and certainly keep working with each other.